In this tutorial video, I will show you how you can control a laser projector directly from a lighting console. I will start with patching some lasers and explain how to set up the projection area for each individual laser. I will guide you through the complete fixture profile and show the similarities to a normal light. Also, I will explain you how you can create your own custom content and upload this to the memory card inside the laser projector. And finally, I will show you a few shots of the lasers here in action. Here, I will use various laser projectors made by the company Covant. The reason for using them is that they have an integrated Pangolin FB4 controller inside all of their lasers. This plug-and-play experience, together with options like the color correction mode, makes them a real convenience to use. They are proven to work in tough environments, and the use of Pangolin scanners gives them a faster and wider projection angle. All you need to know is that a laser with integrated FB4 just works as a normal lighting fixture. You can connect a DMX signal over a 5-pin XLR cable, or you can use the ArtNet protocol to send a DMX signal over a network cable. In the menu of the FB4 controller, you can set up all the needed settings like the DMX starting address and for ArtNet the universe and subnet numbers. So, let's go to the lighting desk and patch these lasers here in our console. Now we are behind the lighting console, we will need to get the correct fixture profile for the Pangolin FB4 controller that's built inside our lasers. In this tutorial, I will be using GrandMA 2 on PC as it's easier to record the output from the screen compared to using a normal lighting console. Each manufacturer has a slightly different approach of distributing the fixture profiles for their consoles. For GrandMA 2, the profile can be downloaded from MA Fixture Share. For all other major lighting desks, the profile can be found in their library, or you can check on pangolin.com to download the latest version specifically for your lighting console. I will download the profile from MA Fixture Share, and as you can see, there are actually two different fixture profiles available for the FB4 SE. The first, FB4 Setup, is used to set up the projection area of the laser projector. The second, which is called FB4 Player, is used to control the laser projector during show. Both of these fixture profiles are needed to enable output from the laser. So, let's go back to MA on PC and start with an empty show file. Open the setup window and go to Patch and Fixture Schedule. Here we will need to add a new layer that I will call Lasers. Now we can exit this window and go to Fixture Type to import our profile. I will import the files that I've just downloaded and copy it to my USB stick. After importing both profiles for the FB4, we can go back and add some fixtures to the layer we have created before. If the import was successful, we will see that we now can select the FB4 SE profiles. In this video, I would like to patch 8 lasers, so we'll need to add a quantity of 8 for both the setup and play fixture profiles. The fixture ID I will set from 1 to 8 for the setup fixtures, and for the play fixtures we will do exactly the same, but here I will set the fixture ID from 101 to 108. This way I can easily recall and remember them, but of course you are free to choose your own fixture ID numbers. Now we have added the laser fixtures, we still need to patch them. The setup fixture requires 13 channels and the play fixture 28. This means that we have a total of 39 DMX channels for each laser fixture. I have already set all the FB4 controllers to listen to ArtNet and set the correct starting address for each laser. The first laser has a starting address of 1, the second 40, the third 79 and so on. First I will select all the setup fixtures, and when I click with my right mouse button on the patch, I can change here the offset to 39, as there are in total of 39 DMX channels for each laser. As starting address I will put here 4.1, because 4 is the output the lasers here are connected to, and 1 is the starting address of the first laser. For the play fixtures I will do exactly the same, including the offset of 39, but now I will use a starting address of 4.14. I choose 14 because this is the first channel the play fixture starts with. Remember, The play fixture comes directly after the setup fixture that contains 13 channels, so it will start with channel 14. As you will see now, all 8 laser fixtures are correctly patched in our console. Now we have added and patched our laser fixtures, we can set up the projection area for our lasers with the setup fixture. First, I will create 2 separate groups for each fixture type, so we can easily select them. When we select the setup fixture, we can go to Control and change the operation mode of the fixture. By default, this mode is set to disabled and we want to change it to setup mode. Next, we need to select a test pattern under Q. The first test pattern will work fine for positioning and resizing the projection area. Now we will need to increase the maximum intensity so we can just start to see what we're doing. Because we are still setting up the laser projectors, we want to keep the output as low as possible for safety reasons. Also, before increasing the intensity, it might be a good idea to check if nobody is standing in front of the lasers and inform anybody who can come close to the lasers that there will be laser output. Now the lasers are projecting the test frame, we can start to change each individual laser to the correct position, size and if needed rotation. For this we use the encoders, and with the next button we can select the next fixture for individual control. If we are completely happy with the current projection area of all lasers, we can increase the maximum intensity. Because I will shoot all lasers above the camera and myself, I will set this to max. All the lasers are now set, and the last thing we need to do is to change the mode of the setup fixture from setup to enable. This will activate the play fixture for controlling the lasers while your projection area is safely locked. If you later might need to change the projection area, you can go back to the setup fixture and change its mode back to setup. First, I have downloaded, imported and patched the laser fixtures into the lighting console. After this, I have set up the correct projection area for all 8 lasers, and now it's time to start playing with these lasers. For this, we use the play fixture of the FB4 controller. Let me show you the presets and attributes that are available in this play fixture. The first preset is dimmer. This should speak for itself and will control the intensity of your laser during show and programming. Note that the dimmer is different as the maximum intensity in the setup fixture that actually limits the maximum intensity the laser can reach. To show the dimmer in action, I first need to trigger a cue in the gobo preset. If we now increase the dimmer, we will start to see the laser output. The second preset is position, and here we have the pan and tilt attribute. Pan and tilt will not physically move the fixture, but it will move the cue within the projection area that we have set before. With gobo, we can select the cue for the laser projector. The cues are stored in different pages on the memory card that comes with the FB4 controller. We can choose from 255 different pages and 255 cues on each page, what gives us a total of over 65,000 cues. The FB4 controller comes already preloaded with default content to give you a plug-and-play experience. Other options we can set here are the cue index and cue rotation. Q index will give the Q a static rotation, and the Q rotation attribute will spin the Q clockwise or counterclockwise. It is also possible to stop the spin and/or to reset the angle back to 0. In the color preset, we can recolor a Q to any specific color with the RGB values. This means we can set the color of the lasers just as easy as any other lighting fixture. It is also possible to mix or fade between the original Q color and the RGB color with the alpha attribute. Increasing the alpha from 0 to 100 will fade the color between the original Q color and the manual set RGB color. In the beam preset, we can set a shutter speed with a range from 1 to 20 Hz. Here we also have some specific laser properties as control over the scan rate. We can lower the scan rate from the original Q speed to 5 kilopoints per second for an additional flicker that will give your lasers that extra punch. We can also control here the visible points of the Q, what means that we can make only a part of the Q visible. This is useful to draw in a Q, so a line, circle or letter can start from a point and becomes completely visible. The playing speed of the Q we can change under the preset control. Here we can pause the Q or change its speed. A lot of default content is exported at 100 bpm, what corresponds to 100% speed. If you change the value for the laser speed to 120, the Q is played at 120 bpm. And last, in the Shaper preset, we can set the size XY and the zoom. Note that there is a difference between these two. The size is calculated after the position preset and the zoom is calculated before. This means that if you make a Q smaller with the size attribute, you can still move it around in your full projection area. When you would use the zoom attribute instead, also the projection area shrinks in size, but will result in a limited movement for the pan and tilt attributes. So that was it, the new fixture profile for the FB4 SE controller. Simple to use and hopefully easy to integrate in your workflow. Talking about workflow, let's switch the MA on PC for a MA2 light so I can show you briefly my setup inside the lighting console. Until now we have used the default content that is already delivered on the memory card that comes with the FB4 controller. But what if you want to make your own custom content? That is what I'm going to show you next. To create and upload the content, we use the Pangolin QuickShow software package. This software comes free with every FB4 controller or laser with integrated FB4. All you need to do is download and install the latest version from the Pangolin website and connect your laser to a computer. If you have more than one laser and using laser projectors made by Covant, you can daisy chain them. Or you can use a switch to distribute the network signal to all your projectors. The FB4 is by default set to Auto IP. This means it will automatically connect without the need of adjusting any IP settings. Optionally, you can set a manual IP address or subnet to integrate the FB4 controller into an existing network. In the laser software, we will need to go to the FB4 settings window. Here we can change the mode for the FB4 controllers. Currently, I have 3 controllers in my network and their mode is still set to ArcNet. We want to change this mode to the software mode called QS Beyond. After changing it, the FB4 controllers will connect to the laser software and in the bottom of the screen we can see which lasers are connected and their status. Now we have a connection with the lasers, we can start to create our own custom content. For this video, I will make 3 different Qs. The first 2 Qs will be beam Qs with custom shapes and colors, and the third Q will be traced from a logo. I will keep the part of creating the Q simple, as this video is not about designing the content itself. Let's start with adding a new page to the current workspace and call it DMX. Now we can make a new Q by clicking on Create New Shape. In the shape editor, we can select the line instead of the circle and activate the beam mode. we can change the size to 100 and the numbers of beams to 16. Also, I will give the beams a little speed by increasing this value to 25. Now we can add some effects to the shape. The first effect will be a color effect, and let's delete that green color and change the red color to cyan. Now I will change the order of the colors from points to radius, so the cyan is in the center and the blue is on the outsides. The second effect is an oscillating effect. I will choose here an X to Y wave and keep the default values for this effect. That's how easy it is, and we have created our first cue. For the second cue, I will be using another editor, the parametric image editor. Here I choose for a line as basic shape. The size I will set to 25, and I will give the line a red color by setting the saturation to max and keep the hue to 0. Note that the endpoints are still white, as I can set the color of them separate from the line color, but I think white looks fine here. Also to this shape we can add some effects. The first effect I will add is a rotation clone effect, and I will make 3 copies of the original shape. Also, I will set the offset from -20 to -50 to increase the spacing between the shapes. The second effect is a rotation Z effect. I will give it the values from 0 to 360 degrees in 8 beats of time. As you can see, the complete image is now rotating. Next, I will copy and paste this effect to make a duplicate and move this to the top, so it will be calculated before the clone effect. This will cause the individual shapes to also rotate, and now we have created our second cue. For the third cue, I will use the auto trace function inside the Quickshare software. Here I can open an image file that I've downloaded from the internet. After opening the image, it will auto trace the file, and I can drag and drop the result to an empty cue, and that quick we have created our third cue. Now we have created our cues, there is one thing that we still want to set up. This is the length of the cue that is used for the export. This length can be modified under the cue properties. As you can see, the first 2 cues we created are shapes that are continuously moving. When we export 10 seconds from this content, we will see a hard cut when the 10 seconds are over and the cue itself repeats. We can kind of avoid this by setting a very long export time of a few minutes, but this will not really solve the issue and will create very large files. Quickshare comes with a very neat feature to solve this, what is called the loop finder. It will analyze the content and search for a place in time where the content itself repeats and will adjust the export time accordingly to this. To start the loop finder, we will just need to click on the button, and here I will select the option to analyze all cues from the current page. I will enable the indicator marker to see if the cue itself resolves within the specified time. As you can see, now all cues have a green indicator, what means that the loop finder did its job and the custom export times are set. Before we upload the content that we have just created to the memory card, let's take a look at the related menus that are important for the FB4 controller. First, we have FB4 Export. Here we can upload the content to the memory card, and this is something I will show you in a minute. Under the FB4 Export, we have the FB4 Browser. Here we can browse through the memory card and upload or download specific files. Next, we have the FB4 Settings window. This window I have already showed you earlier in this video, and here we can adjust all the settings of the FB4 controller. And last, we have the FB4 Viewer, which can be used to view the exported content on a computer. By example, I will now play the file that I've just downloaded from the memory card with the FB4 browser. Now, let's go to the FB4 Export window and see what options we have there. First, we need to decide what kind of export we want to make, as the FB4 controller has different operation modes. Do we want to make an export for DMX playback, or do we want to upload a new test frame? Another option is to upload content for automatic playback, as the FB4 has the capability to play content according to a specific time, schedule, or after it has powered up. Here we will select DMX blank template, as we want to make an export for our content that can be triggered over DMX. A new window will pop up where we can add the content to one of the 255 pages or 255 queues. I will select the page DMX with the queues that we have just created. Also, I need to choose a page to upload the content to. In this case, I will choose page 11. Now I will right-click with my mouse on the first queue and add the complete content of the page DMX to page 11 of our DMX fixture profile. After adding the wanted content, we can click on Export and QuickShow will ask us to save the SD project for later use. Please note that this is not the exported content itself. This is only the assignment of the content to different pages and queues. The content itself will be uploaded directly to the memory card inside the lasers that are connected to the network. Now the export wizard starts and we choose to not apply any correction for color, size, geocorrection, etc. We want to export our content at full size without any corrections for specific lasers. In the next step, we also choose for generic content usable on any projector. Next question is for which projector to create the content for, and here I will select all the projectors. Now we can choose if we only want to export two files or also send the exported content to the connected FB4 controllers. We choose the last option. The final step is to select the folder where the exported files can be written to. This I will leave to the default location, and now we are ready to start the export. Once the export is done, it will send the files to the memory card inside the FB4 controller. The only thing left to do is to check if the export went correct. For this, we will switch the FB4 controllers back to ArtNet mode and trigger the first three queues from page 11. As you can see, the content we have just created and uploaded is now triggered by DMX from the lighting console.